This lesson is going to be about the conic section that's called a parabola. And you have pictured here a parabola on an xy axis. The definition of parabola, which you don't need to write down but listen to, is the set of all points, which is the parabola, that are equidistant between a fixed line. Here's the fixed line. This is called the directrix. And a fixed point that's not on the line, and this point is called the focus. Now, at the bottom of your parabola is a point called the vertex, and it kind of serves as a central place like the center of a circle does. And we're going to give it the same notation as the center of a circle and call it HK. Now, since the vertex is directly in between the focus and the directrix, we're going to give that distance also its own variable, and that's going to be c. So today we're going to focus just on parabolas that either point up or down, and on the next slide we will go over that equation. The equation of a parabola that points up or down, opens up or down, is y minus k equals a times x minus h squared. That looks a little like the equation of the circle. The equation of a circle has two squares, and the equation of a parabola has one square. Now, what determines whether it opens up or down is whether a is positive or negative. If a is positive, it opens up. It looks like a cup, like this example I have here. And if it's negative, your parabola is going to open down. The vertex at the bottom is found by finding the h and the k in your equation. So hk. The focus, which is not on the parabola, it's the one that sits inside the cup. It's right here. You find that, you see that it has the same x-coordinate. So the x-coordinate is the same, but the y-coordinate varies by this distance of c. So we're going to add whatever that c is to it. Now the directrix is a straight line. In this situation, your directrix is a horizontal line and crosses the y-axis, so it's going to be a y equal to, and instead of k plus c, it's going to be k minus c. The last thing that we're going to find when we graph these is an axis of symmetry, and symmetry basically means it can fold in half like you're looking in a mirror, and that line goes down the middle of the parabola through the vertex, and it is perpendicular to the directrix. So instead of y is equal to, you're going to have an x is equal to, and it's equal to your x-coordinate of your vertex. So I've introduced this number a, and how do you find c besides counting? Well, if you're given an equation and you know that coordinate, that coefficient a is going to be 1 divided by 4c. And we will use that information to help us graph parabolas. Okay, for this first example, we're going to graph y is equal to negative x plus 5 squared. Just like with our circles, we're looking for what numbers are subtracted from our x and y to find our center, but except this time we're finding a vertex. So the number that's subtracted from x is negative 5. There's nothing subtracted from y, so that's going to be 0. Now, in order to find the focus in the directrix, we need to know the value for c. And I don't see a number in front of my x plus 5 squared parentheses, but I do see a negative, which means that a is negative 1. So that means negative 1 is equal to 1 over 4c. We're going to cross multiply that, and then we end up with c is equal to negative 1/4. And that's the distance that our focus is away from our vertex and the directrix is away from the vertex. Also, what I notice here is that our parabola is going to open down because it has a negative a, so it's going to look like that. So our focus, I'm going to graph my vertex first. So it's negative 5, 0, so it's over 5 on my x-axis right there. And the focus is in the cup of the parabola, right in there. So that means we're going to go down. So the focus is going to be right here, down a quarter. So it's going to have the same x-coordinate, but we're subtracting a fourth. We're going down. And there's our focus. And the directrix is on the other side, a quarter, like that. It's a horizontal line. It crosses the y-axis, and that's going to be equal to 1/4. Now the axis of symmetry goes perpendicular to the directrix through the vertex, which is the large dot that I put there. And that is equal, x equals -5. Okay. To finish graphing our parabola, we are going to find 4 more points besides the vertex. So we're going to make a t-chart. And since the vertex is the middle of the parabola, I'm going to put it on the middle of the t-chart. And we're going to pick values for x and solve for y. Now I like to pick points on either side of the vertex. And so I have a -5, so I'm going to pick 2 values that are smaller than -5. So -6 and -7 work. And I'm going to pick 2 more values on the other side, and -4 and -3 will work. Keep them kind of close. So we're going to start with substituting in, let's start with -6. We're going to substitute it into our original equation. So we have y is equal to -6 plus 5 squared. And that gives me a negative. Do not distribute your negative. The negative of -1 squared, -1 squared is +1, so that ends up being a -1. Now I want to show you what happens when I substitute in -4. And I'm just going to erase right here and put my -4 into the same place. -4 plus 5 is 1. Again, I need -1. The parabola is a mirror image. So what you have here is, as long as your x values that you pick to substitute are an equal distance away from your vertex, you're going to have the same y coordinates. So it cuts your work in half. So let's substitute in -3. -3 plus 5 squared. That's -2 squared. So that's going to be a -4. And when you plug in -7, that's also going to be -4. So we're going to plot our points. And your parabola looks something like this. Now let's try another parabola, and we're going to put some more detail to it and also complete the square to find our equation. Now we need to put this parabola's equation in standard form, and the reason I know this is a parabola, it only has one square variable. And so we practice completing the square, so we're going to start with getting all of our x terms alone. So we've got x squared minus 2x. We're going to leave a space and add 2y over to the other side. So to complete the square, we're going to add 1, because 1 is half of 2. And we square that. And then we need to factor, so x minus 1 squared equals 2y plus 1. Now in our original equation, in standard form, there is no coefficient on that non-squared. So we're going to factor out a 2, and we're going to actually really just divide it over to the other side, like that. Okay, now this is standard form. I can start finding my vertex, my focus, the directrix, and the axis of symmetry. Vertex is in the equation, and it will be 1, -1/2. And to find my focus, I need to find C. So remember, A is equal to 1 over 4C. A is 1/2. When we cross multiply and solve, C is also 1/2. And I want to go ahead and put this on the graph. So my vertex being 1, -1/2 is right there. And my distance up, because this is 1/2. My distance up to my focus, now this is a upwards facing parabola. Your focus is in the middle and the directrix is underneath. So here's my vertex. I'm going to put my focus in red right there. Go on the other side, and you've got a directrix right down here. Okay, so my focus has the same x-coordinate as my vertex, which is 1, and I've moved up 1/2, so that's now at 0. My directrix is a horizontal line, so that is a y is equal to, and it's down at -1 because I dropped down 1/2. Each one of my little lines here is representing a 1/2 unit. And then my axis of symmetry goes right down the middle, and it goes through the x-coordinate of the vertex. So we've got one point graphed, and we're going to put the vertex in the middle because it's in the middle. And we're going to pick some values for x to solve for y. Now here's a hint for you. If you want to avoid fractions and your a term divides by 2, pick numbers that will give you even numbers inside your parentheses. But we also do have this add a 1/2 thing here, so maybe that doesn't work as well as I imagine. So I'm going to pick, let's pick 2 to go in here. And when I pick 2 to go in to our equation, I will have 1/2 times 1 squared equals 1/2, well, y plus 1/2. So subtract the 1/2 over, so you've got 1/2 minus 1/2 equals y. So y is 0. Now on the other side, if we pick 0 here, okay, the same trick I showed you before, you're going to have 0 there as well. And let's pick another one. I would like to, looking at my equation, I think I will pick 3 and -1. So quickly, I want you to calculate that and then come back and check and see if you got it right. So when I did this, I got -1, 1.5, and 3, 1.5. And when we graph this, again, it should make a mirror image. It's going to look something like this. This is just a sketch because I don't have graph paper, but you're going to have graph paper, so you won't need to sketch. And that's the lesson on parabolas that face up and down. Stay tuned pretty soon for another lesson for parabolas that go left and right.